Well, hello and welcome to Unit 8, which is called Graphing Quadratics. Now, as you're pulling out a piece of paper and writing the title of the lesson at the top of it, you may be asking yourself, Smith, what is a quadratic? Well, quadratic is just what's next. We've done two major types of functions when we've been graphing so far. The first one, if we make a little sketch of a coordinate plane. The first one was something like y is equal to 2x. That was a linear function. A linear function, y is equal to mx plus b, so this is m, the slope. B would be 0, 0, or y-intercept, the slope of 2, so it means rise 2, run 1, rise 2, run 1, or down 2, left 1, down 2, left 1. But linear functions made lines. We talked about linear. We did that all of first semester, was talking about linear functions. And then the last unit that we just got done with, we were talking about functions like y equals 2 to the power of x. Make a little sketch of that one. That was an exponential function. If you remember, what was 2 to the 0 power? It was 1. And then you may remember that, it increased very, very quickly, or start off slow and increase, but then it would increase very, very quickly to almost vertical line. But this end would kind of go closer and closer to 0, but never quite get there. This was an exponential function. Well, now we're moving on to quadratic. A quadratic function, okay, I'm going to do it in red. Quadratic would look like this. Make a coordinate plane. Quadratic function looks like a U. Oh wait, first of all, let's write it down. Quadratic would be y equals x squared. Y is equal to x squared. So look here. First we had 2 times x. Then we had 2 to the power of x. Quadratic is when it's y is equal to x to the power of 2. X squared. Anything squared is a quadratic. And a quadratic looks kind of like a U. Not a V, but a U. Now, you may be thinking, Smith, how can I believe? How you just expect me to believe it's just a U like this? How do I know that you're telling me the truth? Well, here's what's up. Let's make a little table of values. X and Y. And let's go from 3 to 1, 0, negative 1, negative 2, negative 3. What happens with if I take X and take X values, plug it into this function, how would it graph? Well, let's see. If we plug in 3 into x, 3 squared is 9. 2 squared is 4, 1, 0. 0 times 0 is 0, right? But negatives, now be careful here. What is negative 1 squared? Negative 1 squared is negative 1 times negative 1, and negative times negative is a positive 1, positive 4. Negative 3 squared is 9. So look what happens here. 3 this way, it goes 9 up. And I go 2 this way, 4 up, 1, 1, 0, 0. But even the negatives, when I have a negative x, negative times negative is positive, so that's why it comes up here. And it looks it's the mirror image of the right side. It's called the parabola. Now, another thing I need you to know here. Oh yeah, sorry. Yeah, that's called a parabola. That U shape is called a parabola. There's something else I need you to know. This bottom point. Oh boy, here we go. There we go. The bottom point, that bottom point is called the vertex. So the parabola is the whole U, but the vertex is just that bottom point. Alright, so those are some vocab words I need you to get down with for this unit. come on, pen. There we go. A quadratic is anything y is equal to x squared. The shape of the graph is a parabola, and the bottommost point is the vertex. All right, so there's 3 main sections. That was the first. Let's get into our second main section. The next thing I need you to write down is 2 things. I want you to write down Desmos.com, and I want you to write y equals ax squared. So we are going to investigate what a is. We saw what x squared does. It's going to make a parabola like this. But what is this a going to do to our graph? Go ahead and press pause for a minute if you need to. I need you to pull out your Chromebook and go to Desmos.com. Go ahead and pause it while you're pulling out your Chromebooks, and I'll meet you back here in just a second. Welcome back! So hopefully you want the Desmos, and it looks like this. I want you to press Start Graphing. And when you're there, it should bring in this screen here. So here's the first thing I need you to do is the bottom left here. You're going to press Show Keypad. And when you hit that, like your calculator tools come up here. But now I want you to come up here to the left hand side, and in this block of number 1, we're going to graph y is equal to ax squared. Push y equals ax. Now, to get the square, to get the little 2 up there, down here, you get this a squared. You could push, well, yeah, just hit the a squared. Boom, you got ax squared. Then it's asking us, you want me to add a slider? And we say, yes, we do, Desmos. Add a slider. So look at that. There's our parabola. And they give you a slider for a. Go ahead and press pause. Mess around with a. See if you notice a pattern. What changes, what makes the change, and what changes are made. So goof around with that slider for a minute, and let's meet back here in just a minute. Welcome back. All right, so hopefully you mess around with the slider, and sometimes it opens up, sometimes it opens down, sometimes it's wicked wide, like crazy wide. Oh, wider, wider, wider. Sometimes it's skinnier, skinnier, skinnier. And even go the other way. Opens down, wider, 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 but skinny, skinny, skinny. All right, so what did you notice? I'm hoping what you came up with was, oh my gosh, it's always something with my tech, isn't it? All right, there we go. I'm hoping that you notice with A, all right, is that A controls 2 things. It controls the shape, like how wide it is, how narrow it was. A controls the shape, and we'll talk more about that later, but the other thing I need you to know right now is it also does, and the orientation. What do you mean by orientation, Smith? Oh my. Come on, robot. Do what I want you to. There we go. What do you mean by orientation, Smith? So here's what I'm talking about. It either goes and opens up like a parabola like this, or the parabola will open down like this. But when did it open up and when did it open down? I'm hoping you recognize that. It opens up always something. Come on. There we go. It opens up if A is positive. If A is positive, it's going to open up like this. But if A is negative, it opens down. Now, one more thing I need you to know from that is when it opens up, the vertex here, the vertex is that bottommost point. Since it's the bottommost point, it's the lowest point, that's going to be a minimum. But when the vertex is, when it opens down, when the vertex is on top, that's a tip-top point. What do we call a tip-top point? A maximum. All right, so right now, today I need you to know A controls the orientation. If it opens up or opens down, a little camera down here is hard to see. Making a parabola going down like that, right? So there's that. The last thing I need you to know, y'all, this is the third section, is that there are 3 possible scenarios in terms of what we're going to call zeros. What are zeros, Smith? Those are also called roots. What's a root, Smith? A root is a solution. What's a solution, Smith? A solution is an x-intercept. So when we were talking about lines, y-intercept was a big deal, right? But when we're talking about quadratics, x squareds, whoa, x-intercepts are going to be a big deal. So let's draw 3 coordinate planes, nothing fancy. They can be kind of big even. Don't got to be, hopefully not too sloppy, but looking like this. Then I want you to draw a parabola where the vertex is in quadrant 3 and it opens up like this, something like that. Alright, so this zeros, root, solution, x-intercepts, they all mean the same thing when it comes to quadratics. Zeros, roots, solutions, x-intercepts are all the same thing. I'm going to use them interchangeably, so make sure you know that that's what's up. So x-intercepts, how many x-intercepts did we just draw here? Hopefully you can see there's one right there, there's one right there. There are 2 solutions here. That has 2 solutions or x-intercepts or 2 zeros or 2 roots. This all means the same things. This has 2 solutions. Great. Let's go to the third one. Third one, I want to draw a parabola. Opens up where the vertex is in quadrant 2. How many x-intercepts does that got? Hopefully you can see there are no x-intercepts, so that means there are no solutions. No solutions here because it doesn't cross the x-axis. Okay, so I want you to draw what's going to be in the middle here. There's a pattern here. Right? Correct? So like on the left, I have 2 solutions. You see what that looks like. On the right, I have no solutions. What is in the middle between 2 and none? And then, hopefully you know that's 1 solution. But what would that look like? Go ahead and take a second and draw that. Welcome back. Did you draw something like this? Hopefully you drew some parabola that goes down, 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 and then the vertex hits the what? X-axis, and then bounces off and comes back up. This has 1 solution. The vertex is the x-intercept. Looking like that. Alright, so those are the big ideas I need you to know today. Why don't you pull out your homework, worksheet 1, or pass it out if you need to. You can pause and I'll wait for that. What shape does the graph of a quadratic function always have? That starts with a P. Ends in, that's right, a parabola. Hey, for right now, I want you to skip numbers 7 and 8. Don't scribble them out, but just pass them. 13 and 14. I want you to skip those. Then I want you to go down to number 19. You don't got to do 19, but I want to go to number 20 for right now. Number 20, pull out your Chromebook, and we are going to graph y is equal to 2x squared plus 3x minus 4. Pull out your Chromebook and go to decimals.com again. And what we're going to do here is X out our last function that we did. And we're going to put in number 20, which was y equals, what was it? Oh yeah, 2x squared. 2x squared plus, is it 3x minus 4? It is. All right, look at this. It graphed it for us. Now, we can hide our keyboard for right now because we don't really need it. We put in the function, and here is the graph. Now, what's really cool about decimals is you can pinch zoom and all of that. But let's make a little sketch in. Oh man, I'm about to run out of time. Click on the